Hey Algebra 2, I am excited to start the unit circle. We're going to start with the first quadrant. So before we actually start with the first quadrant, we want to talk about coordinate points in the unit circle real quick. So coordinate points so the points x, y are going to be represented. X is going to be cosine of theta, and y is going to be sine of theta. To remember the order, I like to think alphabetically, right? So we have x, then y, so we're going to have c and then s. So cosine theta represents the x distance, sine theta represents the y distance. So we're going to focus on quadrant 1. Because if you understand quadrant 1, then you can figure out the entire unit circle. If you know this, quadrant 1, you know the unit circle. Alright, so let's get started. Alright, so the first quadrant of the unit circle, I'm going to do a tiny sketch of it. So let's have a little coordinate plane. Just the first quadrant. And I'm going to make an arc representing our circle. Okay, so let's say that's just part of our circle in the first quadrant. Lighting is super weird right now. Maybe that'll help. Okay, so we're going to have 3 different angles that we're going to focus on. The lowest is going to be 30 degrees. Then we have 45. I'm going to draw 45 first just so I can be like halfway. Okay. And we have 30, 45, and 60. Okay. So this is, we have 30 degrees, say 30, 45, and 60. 30 also represents in radians pi over 6. 45 is pi over 4. And 60 is pi over 3. So you could think about it as 1/6 and then 2/6. So that's how you get pi over 3. Alright, so an important part of the unit circle is there's going to be coordinates. Okay. So today we're going to focus on figuring out or deriving where these coordinates come from. So we're going to start with 60 degrees. Okay. Let's do some color coding. And this also will work for pi over 3, same thing. So if we look at this angle 60 degrees and form a right angle, if we bring this down, we'll form a triangle, right triangle. Okay. And we can think of this as the x distance, right? This is the y distance, because this will be the vertical distance y, and this will be the x distance. And then the radius of the unit circle is always 1. Okay. So that all being said, we know a thing or two about special right triangles, right? If this is 60 degrees, then this is 30 degrees. So this has the length a, and this has the length of a root 3. So that means that, and this has the length, like, sorry, 2a. Okay. So if this is 2a, then that means that a is going to equal, or x is going to equal half of that. So the x distance is going to be equivalent to 1/2. And the y distance will then be 1/2 times the square root of 3, or we could think of it as the square root of 3 over 2. So that is going to be the coordinate for these angles up here. For 45 degrees, it's a 45, 45, 90 triangle, so let's draw a picture, right? Okay, so this is 45 degrees. I'm going to make a right triangle. Label this as a 45-degree angle. This is 90, so we're turning this into a right triangle in the unit circle. The radius is 1 again. This is going to be the distance x. This is going to be the distance of y. And if we label what we know about a 45, 45, 90 triangle, then this length is a, this length is also a, and this is a root 2. So for this one, you have to do a bit of solving, but that's not bad. I'm going to do it off to the side over here. So if we know that a root 2 equals 1, right, I'm going to divide both sides by the square root of 2. So a is equivalent to 1 over the square root of 2. But if you remember, a radical in the denominator is not considered simplified, so we need to rationalize the denominator. So I need to multiply by the square root of 2 over the square root of 2. And when we do that, we get 1 times the square root of 2, which is root 2. And the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So that means that our x distance is going to be the square root of 2 over 2. And our y distance is also going to be the square root of 2 over 2. All right, and then finally we have our 30, 60, 90 triangle, so 30 degrees. And this is actually going to be pretty straightforward because we kind of already worked with the 30, 60, 90 triangle. It's just 30 is now in the same, I guess, spot as its 60-degree angle was, so our x and y will still be different. Maybe you can kind of predict what's going to happen. So for 30 degrees, right, this is this angle here, or pi over 6. When we have a 30, 60, 90 triangle, remember this is going to be our x distance on the unit circle. This is going to be our y distance on the unit circle, and the radius of the unit circle is 1. So using what we know about 30, 60, 90, this has the distance or length a, 1 has the length 2a, and x is going to have the length a root 3. And you can think about it one of two ways. First way is just the opposite of this, right? Because these are just changed. Or you can just solve again. And if 2a is equal to 1, then a, or y in this case, will be half of that. So y is going to be equal to 1/2. And our x distance will be 1/2 times root 3, or root 3 over 2. So those are the coordinates. If we want to put it all together and finalize what that actually looks like, I'll turn the page for this. Right, then here is the first quadrant. So our finalized version of quadrant 1 is going to look like this. I'm going to draw it a little bit bigger, I think, this time. maybe even mark, say that 1, 2, 3, 4. This will be my 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay, let's see if I can count. Okay, so this is the first quadrant of my unit circle. I have 30-degree angle, or pi over 6. I have a 45-degree angle, and then a 60-degree angle. So remember 30 degrees, or pi over 6. 45 degrees, or pi over 4, excuse me. 60 degrees, or pi over 3. And then the coordinates, like we just discovered, you kind of need to memorize this, but we just went over how to figure it out, so hopefully that helps you better understand. So our coordinates, excuse me, at 30 degrees, our x value is the square root of 3 over 2. At 45, it's root 2 over 2. And at 60, it is 1/2. And then here, our y value is 1/2. Our y value at 45 is root 2 over 2. And our y value at 60 is root 3 over 2. We could also do our axis coordinates, which are very intuitive. Right? So our axis at 0 degrees, well, if this has a radius of 1, right, the x distance is 1. Here the x distance is 0. And then here the y distance, we're not going up at all, so it's 0. And here it's 1, because the radius is 1. So the reason this is helpful is because this is going to tell us what sine and cosine is, right? So examples of how to use it, I could now say, what is sine of 60 degrees? You're going to think, okay, in the first quadrant, I'm going to go to my 60-degree angle, and sine is the y value, right? So our answer is root 3 over 2. So what we're thinking is sine is y value at 60 degrees is this. Another example real quick, and then we'll stop here. Right, I could do what's cosine of pi over 4. So you're thinking x value at pi over 4. And the x value at pi over 4 is the square root of 2 over 2. So this is the first quadrant. We want to be super solid. And then that's going to be it for today.